It's an honor to be here in Krakow speaking with you today. It's actually my second time to speak in Krakow. Hope it goes better than the first. I'm a little bit confused and honored to be speaking behind my friends who are sharing the stage with guys like Neil Ford. Did anybody hear Neil's talk today? Fantastic talk. And my friend Ted will be giving a keynote tomorrow. So I feel a little bit intimidated sharing this stage. For those of you who haven't heard of me, I'm in a slightly different world. I've been spending a lot of time writing Ruby on Rails, and then after that, I worked on a book called 7 Languages in 7 Weeks. And coming out of that effort, I've started to work on a language called the Elixir programming language and a web server for that called the Phoenix web server. But I'd like to talk to you today about a pendulum. And our industry has many pendulums that go across from time to time, from year to year. It has many slow-moving forces that oscillate, like programming paradigms change every 20 years or so. Typing models swing back and forth, fall in and out of favor. But the one that we want to talk about is not a literal pendulum or a weight that swings back and forth, but a figurative pendulum, something that swings back and forth that has a tendency to change over time. Pendulums oscillate. And I want to tell you that you care. And the reason that you care is that it's not enough to go to a conference and learn cool techniques and take those techniques back to work and start trying to hammer on them. You have to know why the industry is moving in a certain way, and you have to know how to tell your boss why technologies are being adopted and why they should care. So I want to give you one chance to boo, okay? And it's coming up right now. I'm going to give you a history lesson. Okay, come on. Boo, boo, shh. But this history matters, and it should have you excited. We're going to talk about the pendulum that moves between batch programming, something that many of you have probably never been exposed to, and something that's a little bit more interactive. And I want to tell you in such a way that you'll understand why so many of the forces, why you see so much disruption in the industry in the last 5 years. Disruption around programming models and architectures. Disruptions around the way that we tend to do things. But we're going to start with batch processing. When I went to school a long time ago, graduated high school in '83, graduated college in '87, my college had just moved out their last punch card system. But the old dogs in grad school would kind of talk about their punch cards, and they would submit this job. They would take these punches and write their programs using punches, submit the job, and then a couple hours or sometimes the next day, they would figure out what the syntax errors were. And then they would finish their programs and debug the logical errors. And it was a difficult way to work. So this is the formal definition of a batch program. Basically means without manual intervention, but it didn't take too long before, back in the dark ages of computer science, that we said, hey, wouldn't it be great if users could provide actual input? And so we had something that looks like this, a form. Should look relatively familiar to you. And then hanging off of that was this thing called a batch script, normally written in COBOL. That's a language, guys. And so you had things that look like architecture diagrams that you see today. But in this architecture diagram, those things coming from the mainframe are actual wires. So we're loading the pendulum for the first time. We're going to start all the way on our left sides. And The Pendulum is going to start with a system called Sabre. Now, Sabre was a reservation system. It was a collaboration between IBM and American Airlines. And when I graduated college, I went straight to work for IBM, and it's an amazing thing to work on a system that was created before you were actually born. But that really happened. And let me read to you what IBM says in their online history museum about Sabre. The Sabre reservation system for airline passengers was the first large, high-speed commercial computer communications network that operated in real time, handling transactions at the time that they occurred. It was developed by IBM for American Airlines over a 6-year period of joint research and became operational in 1962, 3 years before I was even born. But it doesn't take a lot of imagination to look back at that and see those forms and imagine, wait a minute, that thing was a lot like a traditional web application. You take a form, you fill out the form, you press some button to submit the form, the request goes, gets processed on a server, and another form comes back. See, you guys didn't actually invent the internet. This program used templates and batch programs. And this is what COBOL looks like. Brace yourself. That thing on the top is indeed an assignment. Move zeros to amount. Can you imagine writing days and days and years of code like this? Actually, at IBM, there was a joke. When I was at IBM, we were starting to use C and C++, and the new C++ had come out that was, light years better than C. And we said, there's a new object-oriented COBOL coming out. It's going to be called Add 1 to COBOL. Yeah, the slower ones are catching up now. So it's amazing to see the impact that the user interface had on the language and the language, the words used to describe the programming language. Look at this. Picture. And then something that looks like the variable that you're declaring. Picture, an array of 10. This is based on the interactive way that we were building applications at the time. IBM called this system CICS. I think it was Customer Interaction and Control System or something like that, CICS. And it literally took the results of a form, you submitted it, it ran a standalone COBOL program and produced another form. That's what CICS did. But this thing is a pendulum. It stayed all the way to the left for a long time, but it oscillated because that's what pendulums do. And it started to move based on the discovery or the proliferation of personal computers. This isn't the first personal computer, but it was my first personal computer. It was a Radio Shack color computer. It had 4K of memory. Yes, 4 kilobytes. That's what the K is for. 4,096 bytes. And you could store either a word processor or a couple of pages of a word processor document. Couldn't store them both at the same time, right? And if you wanted more memory, later on, another memory chip came out. I said chip. And you had to get solder wick. And you would draw the solder away from the motherboard, hoping that you didn't burn out other important chips. And then you would remove the 4K chip, and you would drop in and solder in the 16K chip, or you had a dad who knew how to do this, and I did. And if you were really ambitious, you would take another 16K chip, and you would break off one pin, and that was a terrifying moment. You break off one pin, and then you soldered it to the top of the other chip, and now you had 32K of memory. And you could fill all that memory up with your crazy color taken tape recorder because it was cheaper than the tape recorder that came with the Radio Shack color computer. Good times. Then there was an IBM computer that came out just a couple of years later, and the Apple computers came out too, and we started to see the personal computer catch fire for business. And it was based on this functional programming language. We didn't call it that, we called it VisiCalc. But something interesting happened if you press delete on one of those numbers. Everything on that page updated at the same time, and users were addicted. And this wasn't just happening at Apple and at IBM, but places all the way across the United States, all the way across the world, were starting to recognize the power of these types of rich user interfaces. And we started to see some research flow, and this is from Park Place, which was a Xerox institution that was connected to Xerox research institution that wound up creating the Smalltalk programming language. This is the Model View controller that talked about the organization of rich user interfaces. And then near the same time, you had the creation of the Macintosh computer and the X Windows system. And I was working at IBM at this time, and we started to see that, hey, there were some customers that would pay a lot of money to actually put the personal computer in place as a business computer. And so we targeted some industries, insurance and travel. That's my work with Sabre and the Sabre 2000 system. It seems like a long time ago now. But we also targeted Wall Street, because the typical user interface at Wall Street was these long pieces of paper, the ticker tapes. And these didn't map very well onto the green screens. And we imagined something that looked like this, where you had these little bits of data, little graphs. All of this was updating in real time. And it was very much not like the request response type of flow that people were used to. So this was the vision. And this was how IBM decided to get there. This is from one of the original design screens from the installation window for the OS/2 operating system. So you had the operating system, you had the communications manager, and get this, when you communicated with your mainframe, it would render a page, and you would look at what the characters were on those screens, and you would scrape them off and that's what your remote procedure call was. That was your RMI. And you also had a LAN interface and a database interface. I worked with the database center. And we were making a couple of pretty big bets. One of the bets was that we could get line of business people. That's people that were programmers, but they were more business analysts than programmer, and we could teach them C. It was a big bet. And we said that there's two concepts that are going to be particularly difficult here. One is that as the pointer moves around, as it floats around, you can't stop the world to make a business request. So we had this thing called fork. You could fire a process. And another thing you couldn't stop the world for was garbage collection. So you manage your own memory, like this. Like this. See, that's a bug. And if you were wrong, C would happily start stomping through memory with devastating impact. But that's where we landed. We said that customers can write C. And we did this with OS/2, and this is what the first lab architecture diagrams look like. Not like this, but something a little bit like that. But there's something missing. The money, right? The mainframes. So we said, not two-tier, N-tier. That's where we're going, right? So if you zoomed in on the server and you looked at it, there's an application on there that takes a process or two, right? Because the second process has to manage the user interface threads. And it took a process for the LAN, it took a process for the database and for the communication manager. So each application had at least these 4 or 5 processes and maybe more. Each one. Right? And it wouldn't scale. So we could give clients a very expensive, rich client experience. But we had a problem. They were writing this in C, and the customers, their workloads were starting to really back up. Right? So the information technology shops, the IT shops, they couldn't keep up with their applications. So IBM made an acquisition, Object Technology International, which built a embedded Smalltalk, which, by the way, became Visual Aids for Java and eventually Eclipse. And if you look really close, you can see two things with bars in them, right? One is the IBM logo, one is the moon, and one of those things is sitting in front of sun, which is a coincidence, I'm sure. Right? So at the same time, Microsoft was going crazy with Windows and was completely tearing that space up. So they sold Windows to the end user, not to enterprises. And then at some point, they decided to cover the enterprise. And about this time, Microsoft released the application that has had, before or since, the single biggest impact on customer productivity. And you know what that is. No, I'm talking about Office. Of course, I'm talking about Office. Sort of. But they targeted the line of business developers, the same people that IBM was trying to target. And they said, well, nobody is going to type public static void main or whatever that is in C. I can't even remember anymore. What they'd like to be able to do is find some button on something that they've laid out graphically, and they'd like to just start typing code, right? And the line of business developer said, we can do that. Until you had a 10K script hanging off of this push button. And then you had 10,000 push buttons with 10K scripts hanging off of those. And then we realized that's precisely the wrong design for an application. So this blew up for a different reason. The mental model wouldn't scale. Back at IBM, we were starting to solve the scaling problem for the database manager. I don't know what the other shops were doing. But we were working on this thing where you had to have one process per application, and everybody knows how to solve this problem. Somebody tell me how to solve this problem, how we do it today. Yeah, a thread pool, connection pool, right? That's what we did. We built a connection pool. And I said, I don't know how to mass produce these, but I know how to mass produce these. Now I'm going to put the intelligence up into that pool. And at the same time, my colleagues were trying to solve the problem of how to do all those things that they said not to do in the first half of this conference, right? That at IBM, everything had to have two-phase commit. And so we wanted to be able to call across this divide with two-phase commit. And we had frameworks to do it, and none of them worked. We had distributed computing environment, we had system object model, distributed system object model, we had Corba. It just wouldn't work. But the pendulum swung because that's what pendulums do. What's this? Anybody know? It is a young crowd. CompuServe? What about this one? I got it. America Online. Yeah. But we had had a taste at that point of what a rich client looked like. And this looked like too much like the old stuff, and it wasn't going to fly. Until we said, instead of serving up text, why don't we serve up something richer than text? Why don't we serve up HTML? And then we have to make that scale. How do you make that scale? We take all that, lop it into state. Okay, I'm going to stop the talk right now, and I'm going to give you a really cheesy analogy. You guys know what cheesy is? You guys use that term? It's kind of the same thing that you would use to describe a very bad dad joke. So I have a cheesy analogy. Has anybody seen this movie? What is it? 51st dates. Very good, very good. So they are establishing a relationship, but the problem is that every night she forgets everything. That's a web application. Right? You say something, you get a response, and you forget. So the key to the explosion of the web was giving our applications this kind of lobotomy. Right? So you take the state, shove it off into the corner, and you build a connection pool for the web. And that's exactly what we did. You take another view of that. There's the application. You throw an intermediary in front, and then we had all kinds of names to describe this thing. This is what IBM was going through. I don't know what anybody else was talking about. But first we had these things called enterprise Java beans, and you had a special kind of bean called a session bean, and you built a facade or an API in front of that, so we called it a session facade. And then we decided that there was too many acronyms, and so we created a new acronym called POJO, called Plain Ordinary Java Beans, a 4-letter acronym. And then we called that thing a command pattern. And then we said, wait a minute, isn't this just like what we used to build, or mostly like what we were trying to build on the Smalltalk front, with controllers and actions, and sort of a model view controller. So the pendulum's on the other side, but we're still trying to do the same thing, right? But the big question is, what happens between the requests? You guys have experienced this, right? And who does that frantic juggling? You do. Now, don't get me wrong, there are many good things about building stateful applications in this way. You can scale it to the moon. And since we did it in a standardized way, this enabled the explosion of the internet. So what we're doing here is we're optimizing this systems code at the cost of the code that the developer has to write, of the code that you have to write. So the UIs aren't rich anymore. You're carrying a heavy burden. In fact, there was a man named Avi Bryant who was writing Smalltalk, and he was working on, he was going to a conference, and he was going to buy a ticket, so he was shopping. He opened one window, navigated to a page, liked that ticket, opened another window, navigated to a page, and the prices weren't as good. So he went back over here and pressed enter. And what do you think he did? He bought that ticket. He got mad and started working on this problem. But that's the kind of problem that we're talking about, back buttons and things like that. So anyway, the pendulum's on the other side, and we're starting to pick up steam. We're building something. We're building with an interface called CGI, which is what? Common Gateway Interface, which is brand new stuff, right? It's not this anymore. It's this. And then we learned to do that with Java. And at IBM, we had this great idea. So at this point, we knew that Microsoft was going to win. Windows was going to kill OS2. And we were selling lots of mainframes, and that was good because mainframes cost a lot of money. And we were selling just a little bit of OS2, and then we'd go to those customers that had the OS2, and they were the same ones that bought these big old mainframes, and we told them, hey, we're not going to do OS2 anymore. Because we didn't think those things were related, but the customers thought these things were related. So they line up all the mainframe computers on the roof, and they said, we're ready to push now. You can pull your OS2. And so we needed a solution. And we decided that we would sell the customers on this idea, which is a better architecture anyway, which can be deployed. You can build your applications down on the client. Instead of on the operating system, you can build them in a browser. And then they liked that strategy, and they did. And it was easier for them to deploy those applications, and that was great. And once that happened, without any fanfare at all, we could snap out OS2 and snap in Windows, because everything was on the browser. And only the appless applets didn't really work. No, servlets, that's the ticket, right? So, so this is the way we wound up building those solutions. And there were a couple of companies that were good at it. One of them was a company called BEA that built a web server, an application server, the connection pool for the web, called WebLogic. And Java made it all possible with this stability and scalability and the organization that it provided, and also this secure sandbox. And with it, we started to see the explosion of the World Wide Web. And I wanted, at this point, to stop and review the types of applications that were happening at the same time. Not as we see them today, not as we imagine that they used to be, but as they actually were. What do the richest applications, the most important of applications of our time, what did they look like when we started? So you're getting the sense that this is real request response stuff. This isn't that different from that green screen that I showed you a long time ago. It was about 40 minutes ago now. But it's a pendulum, and pendulums are going to swing. And eventually, this wasn't enough anymore. So we started to see people that didn't want to compromise anymore. What was the original Twitter built in? Anybody remember? Ruby. Think about that. That's crazy. That blows my mind today. But it was built in Ruby. And the bet was, hey, if our developers can get out in front of everybody else, and if we can deliver code faster than anybody else, by the time that we hit the scalability problems, if we ever hit scalability problems, we'll have a successful platform. And they lived happily ever after, right? No, but they bought enough time to where they could get to the richer stuff. Now, if you were somebody like Google that had infinite resources, you could do this kind of stuff. And that's where we are right now. And a lot of us work at places that aren't Google. And we don't have those kinds of resources. We have this problem now. We have these broken relationships where we're making a request, the result comes back, and we have to forget everything. And we're recognizing that that's not enough anymore. And now we have to go back and repair the lobotomy. So we have to take this pool and we have to remove it so that we could stitch these requests together so that our applications become conversations again. We need to cut out the middleman in a way that makes this possible. Donald, you're fired. Always wanted to say that. So we need stateful applications again. When you're building Google Maps, you have to remember the customer on the other end of the wire. Otherwise, the burden of juggling that state is just too much. It has to be a stateful application. When you're building Twitter, it's not enough to forget the conversation every time. But we don't want the client-server thing anymore because that was just my 24 clients talking to my server, and that's not enough either. We have to multiply times the number of clients that are on the internet. We've had a taste of the internet, we can't go back. But we need a way to replicate that state the way that couldn't scale before in the client server. We want it all. We want both sides of the pendulum. We want the simplicity of the batch the first time. We want the richness of client server. We want the scalability of the web. And we want this to scale thousands of times. And the thing that's going to make that happen are the abstractions, concurrency, and isolation. You can't deal with just one of the pieces of that problem. You have to deal with it all. So I started speaking a lot more in Europe in about 2010. I wrote a book called 7 Languages in 7 Weeks. And it's kind of an audacious title, and that's the point. It's a marketing hook. And when I wrote the book, I was understanding some of these forces, some of the forces around hardware, and recognizing that computer programming was about to change, and it was going to change in a radical way. And some of us would be changing in the base languages that we were writing, like you're starting to hear people talk about functional programming with Java. Some of us were going to move on to more functional languages, but the old stuff was not going to scale anymore. We had to understand how other languages worked. And there was a guy, he's actually from Krakow, his name is Jose Valen, and he was one of the fundamental contributors to Ruby at the time. He wrote some of the stuff that tied the Nginx web server together with the Ruby on Rails server, and he also wrote the security system called Devoxx. And he found 7 languages in 7 weeks and looked at some of the languages in that book and wrote the Elixir programming language. And I'm actually staying with Jose while I'm here for the conference. But it's a cool story because this is a person that recognized the limitations of another language, but he recognized the strengths too. And he wanted to bring those strengths, the same beauty syntactically, the same, the open classes, the metaprogramming, to another platform. So he picked the Erlang virtual machine, and he picked the Clojure macro model, and he picked the Ruby syntactic model and built a language called Elixir. And I'm going to talk a little bit about what we found in Elixir, but many of these advantages can be found in many of the other ideas, languages, frameworks that you've seen at this conference. So the first thing that I want to talk about is abstractions. Luckily, we don't have to do this anymore. We can do this. It's not enough anymore. We need pure functions. The reactive stuff that Facebook is doing is brilliant. The stuff that Evan Czaplicki is doing at Prezi is brilliant with the Elm programming language. So that request response isn't really enough anymore, so that our servers and clients can have rich conversations. Model view controller, even model view controller 2 is not enough anymore. We're still struggling with what this is going to look like. Where do you hold the state? Which parts of this architecture have which rich responsibilities? How can this fit into the worlds with things like microservices? We don't know. So what's next? So a lot of these ideas have yet to be fleshed out. The second idea is isolation. Good enough isolation is not good enough anymore. We're not going to be doing this with threading and locking. We're not going to be doing this with JavaScript. We need something much, much more robust, something that's reliable and repeatable so that when one thread bogs down on your web server, it can't drag the other resources down with it. So it must be supervised. It can't be supervised from within. It must be supervised from a parent. And concurrency is a big deal because, well, we're going to be managing much more state on the server, and that has to have a concurrency mechanism. So we're not talking about hundreds and thousands of requests anymore. We're talking about thousands and millions of conversations. Think Google Maps, not Google proper. So over time, as I came to work with Jose more on this language, he was building a web server. And of course, the web server that he was working on, it was called Dynamo, and it looked just like Rails on Elixir, which had a lot of the same problems that Rails had. and we didn't want that. And a couple of us cornered Jose and said, listen, guy, you cannot build a language and a web server at the same time. He said, well, the community is too small. We don't have anybody that we trust to build a web server. So effectively, we had to find someone, and we didn't know how to find someone. So instead of building a web server, we built a web server kit. We built a Lego kit so that other people could snap that together and build a web server. And then we could start to understand, we could choose from the best web server that came out there. Well, the best one to come out was one called Phoenix. And then Jose jumped onto that product, and I jumped on as an author to help launch this from a marketing perspective. And I wanted to share with you what some of these abstractions have meant to Phoenix. Don't look at this as a Phoenix sales pitch. Look at this as a sales pitch for the whole approach that I've been talking about, for all of the layered abstractions that I've been talking about. So first we said we'll measure this, we'll measure Phoenix versus Rails, and some of you can break into laughter, and it's okay. You know, it's kind of like beating up your little brother, right? Not too exciting. But then we said, wait a minute, what if we did a more real benchmark, and we coded an application in some of the best frameworks in the industry. And we did that about 3 months after the Phoenix was finished. And the results were actually pretty impressive. And then as we added cores, the story got better. So Plug is the Lego kit that I talked about. It's the web server kit. And Phoenix is the web server. And it was the fastest of the things that we tried. Now, what I'm not showing you is that these benchmarks are infallible. What I'm showing you is that as we add cores, the story for Phoenix gets better and better. And that's really, really exciting when you're thinking about the abstractions. So there were some other things we tried. There was a company that was acquired called WhatsApp. Any of you use WhatsApp? Yeah, that's really cool. So in the United States, I could ask that question, and I would hear crickets. But WhatsApp was acquired by Facebook for a lot of money. I don't even know how many zeros. And their big claim to fame was that they could serve 2 million people, 2 million customers on one server. We said, that's cool. What if we tried to put 2 million customers in the same chat room? So that when one person posts a message, it has to go out 2 million times. And Jose said, that's stupid. Let's do it. So we knew somebody at Rackspace, and they opened up some resources to us that we wouldn't necessarily have access to. We had a really fast language that we could use to drive traffic with. Phoenix with Elixir. And we were able to scale this up to 2 million people in the same chat room, and then Jose posted a whole Wikipedia page. Totally responsive. And not just responsive for the fastest few users, but totally responsive for everybody. A very, very small standard deviation. It's a cool message. It's a lot of bandwidth. So that's what I wanted to talk about today, the abstractions that we came up with, and our goal towards moving to the more interactive applications with the publish subscribe type services that the modern applications are driving. So the pendulum is almost all the way to the right. What does that mean for us? So don't think about Phoenix today. What I want you to think about is what types of abstractions are going to get us there. How are you going to get the concurrency? How are you going to manage the results? How are you going to model, is the JavaScript client rich enough for us anymore? Think about how those things are going to impact the applications that you're going to write. And when you go to those sessions and you find something that's particularly exciting, I want you to go back and tell your boss, Not just this is a cool technology, but this is a cool technology that's being driven by market conditions, and this is why we should adopt it too. Are there questions? Thank you very much.